moment. Let's figure out why, okay? So let's take a base. Let's use a base that we like 2. Like the number 2. That seems like a nice logical base to double 8. 2 times 2 is 4 times 2 is 8. So let's look at some powers. Let's go 2 to the 4th power. What's that? 16, yeah? How about 2 cubed? What's that? 8. How about 2 squared? Okay, 2 to the 1st? 2. I want to skip 2 to the 0 for a second. We're going to come back to him. We think it's 1. But let's see if we can, instead of knowing that it's 1, let's see if we can figure out why it's 1. Let's skip. So the pattern here is 4, down 1 is 3, down 1 is 2, down 1 is 1, down 1 is 0. What should the next one be? 2 to the? Negative. If we're using patterns, 2 to the negative first. What's 2 to the negative first, friends? 1/2. Good, it's a half. It's the reciprocal. Negative powers are reciprocals. That's by definition. I mean, that's just how we define it. So 2 to the negative 1 is negative 1/2, or excuse me, is 1/2. How about 2 to the negative 2? Good, is 1/4, 0.25, yes, 1/4. How about 2 to the negative 3? That's 1/8. That's the reciprocal of 1 over 2 cubed, so that's 1/8. And so then the pattern continues as ad infinity, if you want either direction. So now the question is, okay, what goes here? Well, you guys see the pattern here, right? We're decreasing the exponent by 1 each time. How are you getting between 16 and 8? 8 and 4, 4 and 2. You're taking half of each number to get down to the previous one, yes? So if you do 16 divided by 2, you get 8. 8 divided by 2 gives you 4. 4 divided by 2 gives you 2. So to get to the next one, you got to do 2 divided by 2, which is 1. Now that only works on this side. Does it work on the other side as well? To get to the next one, you have to divide by 2. Does that work? And then the pattern continues, doesn't it? So what you've got is a series of completion. I mean, it's 2 to the 0 power is 1 because it satisfies this continuum of exponents. Now, of course, I didn't prove squat here, except for powers of 2. Would it work for powers of, say, 3 or 4 or any other number? Yeah, because that's what exponentials mean. To get from an exponential to the next up exponent, you multiply by a constant. So it won't be 2 for other numbers, it'll be a 3 or a 1.7 or whatever you want. But the same logic's going to apply. The only one it won't apply to is if this number is 0, because you can't divide by 0. But we don't do that anyway, that's dumb. You would never model something that's 0 to the 0 power because you'd be wasting your time. So Aaron, I broke my heart. Hopefully there's a little bit of justification. Continue. It plugs that gap that would be there otherwise. Oh, sad. Now, I'm happy again. Back again. We also had another experiment that we did on Monday, but we never got around to modeling, I don't think, did we? We never ran the model, I don't think, did we? We collected the data. We collected the data, but never modeled it. Experiment number 3 was draw cards so long as you had hearts. So in other words, draw cards until you pulled out a spade or a club or a diamond, right? Draw cards until a spade, club, or a diamond. And Kelly, I'll never forget your response. This will be over quick. This will be over quick. Good. She realized that right away you're gonna triple the rate at which we're losing people, because now instead of stopping when you get 1 and 4 hearts, you're stopping when you get 3 and 4 of everything else. So we got our data. Let me pull the data up here. The data looks like this: X and Y. Hold on, I got the spreadsheet over here. I've got some averages. I think we collected enough to get the data to show itself. All right, until not hard. Good. So we only got as far as 4 trials, 0 to 3. By 4, we were all done. The numbers were 20, 4.5, 1.3 repeating, a sixth, so 0.16 repeating, and then 0. We zeroed out. We never had anybody go more than 3 cards before getting a non-heart. We got very few going 3 cards and getting 3 hearts, which hopefully makes sense. You shouldn't be pulling heart after heart after heart after heart most of the time. I remember there's a workout we do called a deck of doom. I don't know if any CrossFit people in here don't particularly believe in CrossFit, but the workout idea of a deck of doom is fun. You pick 4 exercises you want to do, and you assign each suit in the deck. Have I told you this before about the hearts? Never told you? Okay, so you pick 4 like pull-ups, push-ups, crunches, and medicine ball something or other. And you give the Joker something ridiculous like hill repeats. And you pull the cards out, and you throw the card down one by one. And the card tells you which exercise to do and also how many to do. So we always put an ace as 14, kings 13, queens 12, jacks 11, 10, 9, 8, down to 2. So you always start getting nervous if, say, pull-ups are hearts, and you go through like 20 cards, you've only seen 1 or 2 hearts, because you know you're going to get your butt handed to you soon. And my friends weren't paying attention to that once. We were doing a deck of doom, and hearts were pull-ups. And I knew we were going to get hammered with them at some point, because we hadn't seen a whole lot of them. But what I didn't plan on was we drew the ace, king, queen, and jack, not in that order, but right after each other. And they were all pissed as hell. I'm like, my God, we're going to get a royal flush! I got so excited, but we got something else. It wasn't hearts. But they were like, my God, that deck is broken. I'm like, no, that deck is actually just perfectly fine. We were due for that ass kicking we just got. It's going to happen once in a while. But the thing is that you shouldn't get that right off the bat. Like if you go down to Vegas and you're playing poker, Cassie sits down, puts $5 grand down on a poker bet and gets dealt ace, king, queen, jack, and 10 of hearts. She's very happy, of course. And also it's never going to happen. Because it should not happen if the deck is shuffled. I mean, you shouldn't be getting a run of hearts like that except for 1 in a trillion times or something like that. So the point is that it can happen. So we can have some situations where people are pulling multiple hearts. And I guarantee if we did this experiment enough, we'd have a run of, say, 6 or 7 at some point. It just shouldn't happen very often. And it should trend out to 0. So now my question is, you can't even see that data set. Oh, yeah, you can. Yeah, you can. Now I want the model. So let's run those through our TIs.